Good afternoon. Today we're going to be discussing an upgrade to the lead rec parking systems that are already in place. We wanted to start talking about the lead rec because personally on campus, as we walk around, we see many flaws with the designs, such as very little feedback, and in this case it's very difficult to find. From a human factors perspective, we wanted to create a system that was beneficial for both users and operators, whereby it would decrease the time it would actually take to pay for the parking and also increase potential revenue for the university. And with that, I'll leave you with Max. We'll talk more about specific problems.
All right. Before we start on our design, we had to conduct interviews, and we also went and just observed users in the environment. When we went and observed, we actually went on a really good day for it because it was sleeting outside, and the machine that you have to interact with to pay for the parking is actually located outside. So you had a bunch of people showing up in nothing but gym clothes getting sleeted on, and I think probably the biggest indication that something was wrong was that while we were watching, 4 people actually fell down while trying to use the system, which is bad. We don't want people falling down. When we went and did our interviews, like Nick mentioned, we actually were designing for 2 separate groups, the operators and the users. I'll let somebody else handle the operators section, but what we found out from the users was that they didn't like that the system uses numbered slots on the ground. When you pull in, they said that they couldn't really see where the parking system was. Here's a good example of that. Can you see where the parking system is there? Because it's actually that little dot right there, and that's the only indication you have of where it is. There used to be 2 of them in the parking lot. They took one out because nobody was using it. They probably didn't do that with that one because nobody uses it. The other thing we noticed was that over half the people going into the parking lot weren't paying because the system works so poorly that they weren't getting caught. So obviously something needs to change here. When they were talking about actually interfacing with the machine, their biggest complaint on that was that they weren't getting any feedback, and they didn't even know if they'd gotten through the system correctly. They didn't know if it counted their money, and they also complained that they had to use physical money, which a lot of them didn't have. And there's an on-site coin machine, but it's broken a lot, so people would show up with dollar bills, nothing to pay, and then they get there and they can't pay, and then they just have to leave. And the current system is just horribly designed. It doesn't even work at all. So to go over the things that we needed to change, we decided we have to get rid of the numbered spots. We want to move the machine indoors so people can interact inside. We want to redesign the machine to give clear feedback to the user and to use the U-bill or credit card instead of coins. We want to keep the system efficient and automatic so the staff don't have to deal with it. And the university is not actually earning any money from the system right now because you can't use it when there's snow on the ground because the numbered spots are on the ground and you can't read the spots, so they can't charge you. So we need to get rid of all those things and start fresh.
And then while we were doing the interviews, we also went around to campus just recording all the different parking systems that was in use, trying to decide which one would be best. We found there were 3 major ones. There was the coin-operated parking, the current system at the lead rec, and also the system at the armory. And they also had a new one built into the MU. However, there was a few problems with each. With the coin-operated, again, you have to carry around loose change, and then every half hour or hour, you run outside, put another quarter in. If you're working out, you're all sweaty and it's cold outside. Nobody wants that. With the lead rec, again, we've been detailing all the problems that's with it. It's horribly designed. It's poor user interface. And also, if you go, only way you can see the pay here sign is you park in the northeast side of the parking lot. Only way you can see the pay here sign. And even then, you can't tell where to pay just with the utility box. And so that's, again, poor designing.
The users, the faculty and staff, and the students that are using the lead rec and the maintainers. And the problem with the maintainers or the parking division, is that during the winter, the numbered spots, you can't even see the numbers on them. So the users aren't going to pay for something they don't know what they're paying for, and they can't ticket someone if they're, it's not even possible to use. So we decided to move everything from outdoors to indoors, because that's the most convenient way that people want to use these. No one wants to stand outside and pay for something and be adapted to the elements such as ice, rain, etc., etc. So we thought about the key steps. What would I want from going to the rec? I want to pay exercise leave. That's all. I don't want any extra steps. So we started implementing them into a Wizard of Oz prototype when we're the operators, and decided we wanted the users to go through and test what we have already learned from all of our research.
And like we discussed earlier, we had when we designed it out, we had two main tasks. We wanted to have the person be able to find the system quickly and efficiently, and then also when they were interacting with it, we wanted to have them be able to understand how they're interacting with it, and also be able to receive feedback if they've interacted with it properly, so they know that it works and will decrease in frustration for everybody who uses it.
Now we're going to actually have somebody come up with the system that we designed. We did storyboards and stuff to get the steps down, and then we actually made a paper prototype, and this is just a digital version of the paper prototype. So you're going to have.
All right, I'm just going to give you a quick walkthrough. As you come in, this will be what you see as you come in. This is the only entrance. There will be a gate down, so you can't even get into the parking lot without interfacing with this. Please interact with the system.
Push the button.
And you get your ticket.
Got my ticket.
And on the ticket, it actually has instructions on what to do next.
Okay, you go inside, you work out, you do all that stuff, you take as long as or as little as you like. There will be another system right here. As you walk in, it'll be to your right. As you're walking out to your left, and when you leave, you take your ticket, make sure you keep it with you. You take this, interface with the system.
Alright, I would put my ticket and put an entrance ticket.
Okay, and you'll get,
I would put on my U-bill account, so I'd slide a U-bill.
alright?
And then I would take my student ID and I'd slide it where it says credit.
Yes, sir.
And then I would put some,
Yep.
You just got your.
You just got it paid for.
and I would
Take
my
your exit ticket.
That's off the exit ticket.
And as you leave, there will be one on the other side with another gate down. So you need to take this ticket, and you will see this.
Alright, I would take my exit ticket and put it in there.
And the gate will lift, and you will be on your way.
And that's the whole thing.
Our prototype all came out to be 100% because our system was designed to the constraint that you couldn't get through it with making errors. You couldn't finish the experiment without going through it correctly. But in all reality, if this system was implemented, there would be problems that the user couldn't help, such as computer error or maintenance error or hardware error that isn't the user's fault, obviously.
When we were doing all the steps that we did were from a human factors point of view. So, like she said, we did everything from the standpoint of constraints.